going to look at a tsibble index. This slide is showing you how to construct a tsibble. And look over here, we are basically going to call this data set that we are constructing my data. You can call it whatever you want. And this is basically going to be constructed using the tsibble function, which needs a few arguments. So one argument that it needs is the index, right? So because it's a time series tibble, it does require us to identify what the temporal or the time series component is. So it needs the year, but it doesn't know what the year is. So why don't we tell R what year we are talking about? So let's say we wanted to go year on year from 2012 to 2016. So you can say year equals 2012 colon 2016, right? And this is going to give you 5 values, right? So you have 5 values here, and then you can give your time series y is just a vector of 5 values, right? That are going to be associated with each of those years. Then you specify the index, and then you call my data, and it gives you a tsibble. So notice over here that you have 5 rows and 2 columns, right? You have the year, which is an integer, and your y, which is your time series of interest, is measured as a double, a numeric vector. Okay, so the next thing we want to do is understand how do we go from having a tibble to making it a time series tibble or a tsibble. Now let's say my data, I hope you'd erased my data before, so clear that. But let's say my data is now a tibble, not a tsibble, but a tibble with the same sort of things that we had before, right? With the year, with y, but it doesn't have an index command, index argument here because it's a tibble, okay? Now we're gonna use the pipe function. The pipe function just is gonna do the operation, this operation on whatever you wrote previously. We're gonna store it, store this tibble as a tsibble. So the way to do that is using the as_tsibble command. And when you do that, it always needs this argument which says index, right? So notice the index is always going to be whatever you had over here, whatever you specified here, okay? So you can always do question mark tibble or question mark tsibble to understand these things, and also for this command, question mark as_underscore tsibble to understand the arguments that go into this function. And then you're going to call my data again, and look, even though we didn't create tsibble in the first step, you know, we used the pipe function, we did this in 2 steps. Now we have the same thing as before in the previous slide. tsibble, again, we have 5 rows and 2 columns and annual data. Okay, but what do we do if we have observations that are recorded more frequently than just once per year, right? So in that case, we always want to look at a Timeclass function on the index. Okay, so let's take a look at what we're given here. We have z over here, which is a tibble, again a 5x2 tibble, but instead of year, in the first column we have month. So for each year we have a month associated with it and a value associated with it, okay? So we have a monthly series, but it is stored as a tibble. We want to make sure we store this tibble as a tsibble, but also tell R that we have a monthly frequency in our data. So let's see how we can do that. Now the way to do that is, let's call z, right? Z was our tibble. We're going to use the pipe function on it, and we are going to use the command mutate. you're familiar with this command, if you are familiar with the tidyverse. So what mutate does is it helps to create a variable or manipulate a variable from your data set. Okay, so I'm going to create um, a variable called month. Okay, and that is going to be equal to year month, and in brackets month. Okay, so what year month does is um, it takes whatever is in here, right, which is already in the data set. So earlier we had month, which was given to us. Your month is going to operate on month, and it is going to record month as a monthly time series. Earlier it wasn't, even though the column itself said month, it wasn't recorded as the index of that data set. So now what we're doing is we're just naming the new index as month, and we are calling year month on the original column. Okay, and then we use the pipe function again and store that as a tsibble using the as_tsibble command with now the index equals month. Okay, and notice what happens. We have a tsibble now with 5 rows and 2 columns as before, and we have something here, which is our frequency, which is monthly. Okay. Now, you might come across a lot of different data sets with different frequencies, and so anytime you want to store it as a tsibble, you would want to know the frequency of the data and store it correctly. And for that, these functions are very important. Okay, so right now we had just used the year month command, which helps us store monthly data, but you can also do year quarter, year week, and things like that. If you really wanted to go into more fine details, if you had higher frequency data, right? So if you look at the column, we are going from low frequency, which is annual, to high frequency, which is daily or sub-daily. Or it could be like seconds, this is if it was stock data or exchange rates or something like that. Okay, so you can have more complicated functions that take care of that. There's actually an interesting section in the book which is about seasonal periods, and I think you should check it out. So let's take a look at an example of the Australian prison population. Now, we are going to encounter many situations where data sets are not going to be in tsibble formats, and we always want to store them as tsibbles if we want to do any type of operation on them in the tidyverse universe, or even whatever this book is teaching you. So you want to be careful about that. And we always want to read data into R, clean it up. Once we have a tibble, we can then store it as a tsibble, okay? And you can specify any index or key variables that you have. So here's an example where we are basically looking at the prison data set, okay? This is all in your book, so you can take a look. We are basically going to store this data in the in the prison data frame or prison table. Okay, we are going to use the readr function to read our CSV file in this way. We are going to call our CSV file, and notice it tells us that this is a tibble, which has 3072 rows and 6 columns. And when we look at the dates here, right, this seems like, well, the date isn't changing, right? But you can always do head and tail on prison to see head prison or tail prison to see, what the data set looks like. You have this data set has dates that are days, but the data itself is quarterly. That's what you're going to find. Okay. So this data set stores data on the size of a prison population in Australia, which has all of these keys like state, gender, legal status, etc. Okay, and also indigenous, you know. So what do? We can first call on the CSV file, import it into R using the readr function. Then the next step, we use the pipe function to mutate. Okay, we're going to create a new column called quarter, which is going to be equal to year quarter of date. Date is what was given to us already in the table. Okay, so notice at this step, we haven't really stored our time series as a tsibble. All we are doing is we are mutating it. So we really need one more step. So wait for it. Not yet. Okay, so what we can do is we can get rid of the date column, this ugly date column that we had, because now we have this really neat looking, on the right we have very neat looking quarterly index. We don't need this to, and this would confuse us if we had it. So we're going to get rid of it by just doing a column operation that says minus date. Okay, and it gets rid of it. So what you want to do is at every step, if you're not comfortable with the pipe function yet, and you cannot really see the steps one by one, and you don't want to do it all together, do it one by one and take a look at what is going on in each step. And then, you know, as you get more practice, you will be able to get this perfected. So let's take a look here. What could we do? So we're fine until here. We just subtracted off date. We can do another operation. So the next thing we're doing using the pipe function is storing it as a tsibble. And now we have the index, right, that we have to always specify, which is going to be the quarter, which we had generated before. And then we can also specify what keys are associated with this tsibble. Okay. With the keys could be state, gender, legal status, indigenous, etc. Okay, so in this data set, you have about 8 states, 2 genders, 2 legal statuses, and 2 indigenous states, right? So if you do 8 times 2 times 2 times 2, you're going to get 64 different time series or unique time series. Okay, so let's take a look at an example of the Australian pharmaceutical sales. So there is a benefit scheme in Australia that basically is something that's issued by the government. It's a subsidy scheme for some drugs in Australia. So this data set has sales data on those products. And this data is also monthly. It goes from July 91 to 2008. I think you should just work with this data in R and see what you observe from the data. And if I am right about this, this is also classified according to various concession types, which we'll see, or some kind of an ATC index, which is anatomical therapeutic chemicals. And we can try to ask ourselves, what if we are interested in calculating the cost of the time series, right? That is measuring sort of the total costs in Australian dollars of some of these drugs. Okay, so I mean, a little bit more about this data set. There are many drugs that are bought from pharmacies that are subsidized to allow more access to these drugs. The cost to the government is typically determined by the number and types of drugs purchased, and currently this is about 1% of Australian GDP, and the total cost is budgeted based on the forecasts of drug usage. So you have many different types and categories, and you have about 336 unique time series in the data set. Now, why is this important? It's a complex data set, but why is it important? if you're able to forecast based on prior information what these sales are like, then you can let the government know and they would be able to budget better. So let's take a look at this data set. It is called PBS. Okay, and notice this makes our job a lot easier. It is already stored as a tsibble with 65,219 rows and 9 columns. And this is measured monthly, like I said before. Okay, so you have the first column, which is your temporal index, and then you have different keys right here, which tells you the concession, the type, co-payment or not, ATC 1, ATC description, ATC 2, and so on and so forth. And then you are measuring scripts or cost in the last 2 columns. Now, if we wanted to extract just ATC, just A10, right? You're seeing A10 over here. This is a character vector. The way you can do this is by just filtering and extracting those rows that contain A10 if you wanted to focus on A10, okay? So for a particular key, if you wanted to extract the particular factor, this is how you would do it. So you would say PBS, pipe function, filter. Now filter acts on, it's a row operation, so it's gonna operate on these rows that you're seeing. And we're gonna say the column name, which is ATC2 equals A10, because this is a character vector. Notice over here, you might, yeah, right here, okay? So ATC2 is a character vector, so it has to go like this. So it's gonna select, this is gonna select all rows with A10 scripts. So we can use the select function, and this is a column operation, to select the column that we are interested in. So let's assume we were just interested in the cost of A10 drugs, and then we're going to do this in 2 steps. So we're going to take the data set, we're going to filter by the row, right, by rows, and so A10. Then use the pipe function again and select the cost. Okay. Now, if you select an index called month, which is your first column, it's not going to work because it's not a valid tsibble. Okay. What it needs is a unique identifier, right? So you have to give that month, comma, cost or something over here. You can try this. I think you have to go wrong to understand what will work. So over here, we can again filter by A10, select month, concession, type, and cost. You don't really have to write month automatically if it's stored as a tsibble. It will just always give you the index along with whatever you select out of those keys. Okay, so you have, out of those columns, right? Whatever you're interested in. So what you're doing here is you're extracting a much cleaner data set. Okay, for A10, we have all of A10s, right? We have the month, we have concession, we have the type, and we have the cost. Now, we can always use the summarize function, which is very interesting. Typically, we are doing all of this work, whether we are doing row operations or column operations, to actually get to some kind of a summary statistic that will inform us about something. So the summarize, this is written with an S. They're Australians, but we write it with a Z. Both will work in R. Summarize or summarize both work. And summarize works, it's an operation on whatever you're calling. So you're saying, well, sum the cost, okay? and before that you've done all of these operations. So what it does is that it allows us to combine data across keys. And in this example, we wanted to compute the total cost per month regardless of the keys, right? So that's what we're doing. We're saying, what is the total cost? And it basically gives us the total cost for each month, right? So notice that you have 1991, July, then 1991, August. And if this is what you wanted to get to, these are the steps you would have to follow for that type. Okay, what if you wanted to change the units? Maybe you don't like all of these big numbers, right? You want to measure these variables in millions, right? What you could do is you could mutate, right? Mutate is literally mutating a particular variable. So you have total cost is our variable, which is now going to be equal to total cost divided by a million, right? Just to change the units in millions, we can just divide it by a million. And this is a very neat way of writing a million. 1 e to the e6, right? You don't have to put anything, but this is really a million. Okay, so it has 6 zeros, in other words. And so here, this is the output. You have a neat column now, and you can, well, basically say that in 1991 July, 3.53 million Australian dollars was the total cost of whatever drug. Right? And then I guess sometimes you just want to store that data, right? So what you can do is once you have done all of these operations, you can just say, right arrow, and then you do A10. Okay, so you remember what it is that you were storing. So I guess if you're comfortable with this, I think you can do some exercise on your own. And I will stop the video here before we continue with the next video. So have fun with this.